Hey, folks, and welcome back. Today, we're going to be moving into our new topic for our motion unit, which is we're going to be talking about acceleration. Okay, so what is acceleration? Well, acceleration is a change in an object's velocity. Now, you'll notice that I'm not talking about the speed, right? Talking about a velocity. And because it is based off of velocity, that means that acceleration is a vector quantity. It's a vector quantity, which means that it's telling us something about the direction, okay? Accelerations can be positive or negative, and them being positive or negative means different things. So that's what we're going to be taking a look at today. Now, acceleration can be either a change in an object's speed or an object's direction. Now, you're probably wondering, why am I using the word speed here? Well, remember that velocity is both speed and direction. Okay, so when we talk about acceleration, we're talking about either changing an object's speed, right? So either getting faster or getting slower, or we're talking about changing the direction. So an object turning, even if the speed stays the same, is accelerating, okay? Because its velocity is changing because the direction that it is traveling is changing. Remember, velocity is speed and direction. So changing the speed or changing the direction both result in an acceleration. Now, our units for this are either meters per second or meters per second squared. That's kind of the shorthand for that. So what does meters per second mean? Well, remember that velocity is measured in meters per second and speed is measured in meters per second as well. Well, we're talking about acceleration, which is a change in velocity, right? And that change is occurring over time. And so it's not just meters per second, it's how much is your meters per second changing each second, which is where the second comes in, right? Meters per second is telling you how much is the velocity changing each second. And so meters per second squared, again, is just kind of the shorthand for that. You will see meters per second squared more often than you will see meters per second, but they mean the same thing. Now, let's take a look at some examples. A change in speed, right? So here we've got Winter Soldier and we've got Black Panther, right? Both of them, when they fall to the ground, their speed is zero, right? They're stopped. They're not moving. When they start running, right, they are increasing in speed, right? So they are accelerating. They're moving faster, right? And so that would be an example of acceleration. In our second example, we've got Falcon, right? Falcon is falling, and then Falcon kind of spreads his wings and turns. Well, when he's turning, right, changing his direction, that is a change in velocity because he's changing direction. So he is accelerating, even if his speed is staying the same as he does so. Okay, so both of those would be considered acceleration, either a change in speed or a change in direction. What is the difference between positive and negative acceleration? Okay, I mentioned at the beginning that we could either have positive or negative accelerations. A positive acceleration means that the object is speeding up, it is going faster. A negative acceleration means that the object is slowing down. Okay, so a positive acceleration, speeding up, negative acceleration, slowing down. So our example on the left, we've got Winter Soldier. Winter Soldier, you'll see at first he's running, right? He slows down, so he goes through negative acceleration. Then he slows down the motorcycle, which is also a negative acceleration, right? So we've got two examples of negative acceleration in the first video, right? Winter Soldier himself slows down as he approaches the motorcycle, and then once he grabs the motorcycle, he slows it down, which is also negative acceleration. And then positive acceleration would be once he hops on the motorcycle, right? He's stopped, he's not moving, the motorcycle's not moving, and then it accelerates and he goes forward, right? That's positive acceleration. He's speeding up and going faster, okay? So a negative acceleration means that we are slowing down. Positive acceleration means that we are speeding up. So how do we actually calculate acceleration? What is our formula? Our formula is that A, which is acceleration, is equal to VF, which is the final velocity, VI, which is the initial velocity, so it's the final velocity minus the initial velocity divided by time. Why are we doing some subtracting here? Well, remember, acceleration is the change in velocity. So we have to find that change by taking what our final velocity is. That's the velocity at the end of the acceleration, and subtracting what was our initial velocity. What was the velocity at the beginning? Okay, and so that tells us our difference, and this is where we can get a negative answer. Because if our initial velocity is greater than the final, then our acceleration will end up being negative. And it's very important that you keep that sign. And it's very important that you get the final and the initial velocities on here correctly, so that way you have the that way you get a negative acceleration if you should, right? So there are some scenarios where the object is slowing down. You should be getting a negative acceleration, right? Make sure that you write these, what the different symbols stand for in your notes. All right, so let's take a look at an example problem. All right, and so here we have Captain America starting at rest. Okay, so he's starting at rest here. What does at rest mean? Well, if you're resting, you're not moving. Okay, so he starts at rest. You're not moving. What would your velocity be if you're not moving? It would be 0, right? So this is our initial velocity. And remember, whenever we have these word problems, we want to make sure as we're reading through to kind of mark down what we get. So he's starting at rest, and then he starts running, just like we see in the video clip. After 2 seconds, okay, what's 2 seconds? That's our time. He jumps from the building, and when he jumps, so after that 2 seconds, he's moving at 5 meters per second squared. So this is at the end of the acceleration. This would be his final velocity. So the question is asking, what is his acceleration, right? Well, this is A. This is what we don't know. So we're trying to find acceleration. So let's start off with our equation. Acceleration is equal to final velocity minus initial velocity divided by the time. So let's fill this in. That's going to be equal to 5 meters per second minus the initial velocity. Again, that was at rest. Rest means that you're not moving, so it would be 0 divided by the time, which is 2 seconds. So 5 minus 0 is 5 meters per second.